Hello, class. This is Nasreen, and welcome back to the chemistry class. Um, I will be, I will try as much as I can to explain in this video the moles. We stopped at some in the middle of this chapter 7. So we'll continue working on it, but it's the same concept. We're still talking about the mole and how the mole actually is a and what is a mole. If we can recall what is a mole, it's a unit that we use it because sometimes we use in chemistry chemicals that's actually less than the gram units, so we have to use something less. And we talked last time about how to change any formula from mole to atom. And if you try to remember, so from mole to atom, we always use the Avogadro's number. From mole to mole, we use also Avogadro's number. From mole to grams, we use the molar mass from the periodic table. So we calculate the molar masses based on the periodic table. And from mole to mole, we use the ratio in the equation. And from molecules to atoms, we use the subscript in the formula. So the last one means if, for example, you have our famous molecule, which is the glucose. So it means that this molecule, one molecule of this has 6 atoms of carbon, 12 of hydrogen, and 6 of oxygen. So these are all the formulas that we were talking about and everything. This is just to memorize. So we covered all of this before, but today we will practice so we can refresh our memories. And we also will do another topic that's called limiting reactants or the limiting reactant. Limiting reactant, we'll talk about it and we'll talk about how to calculate it if it's in mole, which would be easy. If it's in grams, which would be kinda not easy. We'll see. So let's start. Let's start with practicing. So from the book. So here is from the book. So the given. The given in this equation will be, we have 4 moles of sulfur and we need to turn them to see how many the needed here is how many how many atoms of sulfur. So this is the problem basically, and will explain number both of these, but this one specifically will actually explain the atoms and the moles. So the first thing we do here is that we need to extract more information. The information that we can extract is we have here atoms and moles, then there is a relationship between them. We go back to this, so it's Avogadro's number actually can connect between them. So we can add in the given side that we can add that 1 mole of sulfur has actually 6.02 times 10 to the power of 23 atoms sulfur. Okay, and now because we have an equality, then we can have conversion factors. So we can have, let me, so we can have 1 mole divided by 6.02 or the opposite, Avogadro's number. We'll write it this time as Avogadro's number for short, and 1 mole of sulfur, atoms, sulfur. Okay. So now we start with our input or the given 4 mole sulfur, and then now we need to decide which conversion factor we should use. So we need to get rid of the M for the mole, so this has to be in the bottom. So we will have number number 2 here. So here 6.02 times 10 to the power 23 atoms S. Now it's time to check if we reached the needed we actually need, or the information that we need. Atoms. So we will, this will cancel that, and then we will multiply 4 times 6, and we get the results here in atoms of sulfur. Okay, so this is to go from mole to atoms. If we do another example to go between mole and molecule, let's use another example. Okay. So the second example will be given. So this is the second example, and then needed. The given here in this problem is that so the problem, how many molecules are present in 1.75 moles of carbon dioxide. So how many molecules CO2, okay, given here in 1.75 mole CO2. So you look here, you find that the relationship will be between moles and molecules. Then you figure out that you actually have option to add Avogadro's number equation, and then, or equality, and then after this you extract your significant figures. You extract your conversion factors. So we can add here that 1 mole CO2 has Avogadro's number, molecules, CO2. And then we can have the first conversion factor can be 1 mole CO2 and Avogadro's number, molecules, CO2, or Avogadro's number, molecule, CO2 divided by 1 mole CO2. Okay, now we start with our given here. So to set up our equation, 175 mole CO2 times, we need to get rid of moles CO2, and that's on the top of the or denominator. And then so we need to get rid of it, so we'll be using this one here, so I can actually get rid of it. So times Avogadro's number, molecule, CO2, and then divided by 1 mole CO2. Then here, what you do, you will cancel mole CO2 and mole CO2, and then you check, is this the last thing that you need in your equation? Mole CO2, is this the unit you need? Yes, that's the unit you need actually. So you finish up your calculation. It's very important to look at the last thing or the last part of the calculation to make sure you got the needed correctly. So you do your calculation, and then at the end you will have the results as molecule CO2. So here we basically went over how to go from mole CO2, mole to molecules, and also moles to atoms using the Avogadro's number. So we did this, and then we did this, and now we will try to connect the mole with the atoms or the molecules and the grams. So we will be doing number 3. I think I will do number 3 in another video. So it's better to put it all together in one video instead of just cutting off the explanation. But I will just give you here an introduction about the molar mass. Again, the molar mass, you can get the molar mass from the periodic table. So in the periodic table, you can, for example, the sodium, you can find 1123, right? So 22 point whatever, 1. So you get this number and just add them together, and you can get your molar mass of the molecule. So this is the molar mass of only Na. If you're doing the molar mass for example, NaCl, then what you need a whole molecule. So this is an atom. This is a whole molecule. To get the molar mass, it's the one right away in the periodic table. To get the molar mass of this, you need to get the molar mass of this from the periodic table, add the molar mass of this, I think it's around 35, and then you add them together, get the number, and then you will have your molar mass of NaCl, which will be 85. So any molecule that has many atoms participating in the molecule, it's very easy to get the molar mass, just like C6H12O6. Basically what you're gonna do, so the 6 is 12, H is 1, and oxygen is 8, 16. So you can see these numbers here. You will apply the subscript for each one. So for example, here you can say, if you want the molar mass of the glucose here, what you can do is you start with this carbon, and the carbon is 12, but you have 6 of them, plus, that's for the carbon, the hydrogen, you have the molar mass is 1, but you have 12 of them, and then plus you have here the oxygen, which you have here 16, but you have 6 of them, and then you add everything together and get the molar mass of, you get the results of this, and then that, and then that, and then add them together and you get the molar mass of the glucose. So this is basically how we can calculate the molar mass of a molecule. This is a general idea. I will go in details and examples in the next video, video number 2, and I will explain how to move between moles and grams in the next video. Okay,